today I will discuss about the sign for members under combined forces. Members subject to combined axial force and bending moment are called beam column. So since alam naman natin 'di ba na yung tinatawag natin yung structure natin, kino-consider natin yung structure natin as a beam kapag ang purpose niya is mag-resist ng transverse loading. Wherein yung transverse loading na yun is nagko-cause dun sa structure natin, sa member natin na magkaroon siya ng bending moment, ng bending stress. And then, yung structure naman natin na nagre-resist ng axial force, tulad nito, let's say may compressive force tayo, tinatawag naman natin yung structure natin as column, 'di ba? So, kailan nagkakaroon ng tinatawag na beam column? Halimbawa daw is meron tayong axial load and then meron pa tayo ditong lateral load. So, yung structure dito is matatawag nating beam column na siya, kasi nagre-resist na siya nung axial force, meron pa siyang magkakaroon pa siya ng bending moment due to lateral load. Or kundi naman lateral load, pwedeng meron tayong applied moment dun sa structure natin. So, yun. So, yung provision na gagamitin natin dito are based on NSCP 2001. So, unahin natin yung axial compression and bending. When a member is acted upon by these loads, the stresses produced axial stress and bending stresses is not added to obtain the combined stresses. Additional stresses resulting from a secondary moment caused by the P delta effect, so P delta effect, must be taken into account, especially when the member is subject to large axial compressive force. So, hindi lang basta-basta natin pinag-a-add yung axial stress and then the bending stress. So, may i-consider daw tayong amplification factors para ma-taken into account yung mga secondary moment. So, meron tayo ditong dalawang condition. Una, yung tinatawag nating small axial compression. So, mako-consider nating small axial compression siya kapag yung actual axial stress over the allowable axial stress is less than or equal to 0.15. So, dito siya papasok. However, kung siya naman ay greater than 0.15, so, dito sa provision na to, siya papasok. So, unahin natin yung small axial compression. So, yung formula na gagamitin natin is ito. So, meron ulit tayong interaction equation. Kung mapapansin nyo, parang ito lang din yung sa pag-design natin ng purlins wherein meron siyang biaxial bending. Meron siyang flexural stress sa X and then sa Y. So, simple lang yung formula. Substitute lang natin ito. Yun na yun. So, pagdating naman kay large axial compression, ang mangyayari, meron ka ng dalawang criteria. So, yung unang criterion is for the stability interaction criterion. So, ito yung formula niya. Kung mapapansin nyo, meron na tayong additional variables na C sub mx and C sub my and then the f prime e x and then f prime ey. So, and then pagdating naman kay strength interaction criterion, wala na si C sub m. Yung reduction factor. So, yung C sub m natin is called the amplification factor or the or the reduction coefficient. So, at ito yung mga condition. Mayroon tayong ilan ba to? Tatlong condition para makuha yung kung ano yung gagamitin nating value for the amplification factor. So, first is for compression members in frames subject to joint translation, C sub m is equal to 0.85. So, ibig sabihin kung yung frame mo is hindi niya nire-restrain yung side sway. So, yung C sub m will be equal to 0.85. And then, second condition, for rotationally restrained compression members in frames braced against joint translation, so meron na siyang bracing, but not subject to transverse loading. Ibig sabihin, wala siyang mga lateral loads. So, yung C sub m daw natin is equal to 0.6 minus 0.4 multiplied by m sub 1 over m sub 2. And this value should be greater than or equal to 0.4, where m sub 1 is over m sub 2 is the ratio of the smaller to larger moments at the ends of the portion of the member unbraced in the plane of bending under consideration. So, ibig sabihin dito, laging less than 1 yung makukuha mong ratio dito since yung nasa numerator mo is yung smaller moment and then yung pangalawa is the larger moment. So, yung m sub 1 over m sub 2 daw natin is positive when the member is in reverse curvature. Kung ganito yung magiging itsura nung pag-bend nung member mo. And then, negative naman siya when bent in single curvature. So, kailan mangyayari yung single curvature and reverse curvature? So, kung mapapansin nyo, dito, yung applied moment dun sa top end nung column natin, meron tayo ditong moment na counterclockwise. And then, dun sa baba niya is counterclockwise. So, ibig sabihin, kung reverse kung magkabaliktaran yung moment mo at both ends, therefore, magkakaroon siya ng single curvature. Magbe-bend siya into single curvature and then dun naman sa halimbawa dito naman sa reverse curvature, kung mapapansin nyo yung moment niya dun sa end is meron tayo dito counterclockwise and then another counterclockwise. Therefore, ang resulta magkakaroon siya ng reverse curvature. So, dito sa pangatlong condition, braced against translation pa rin siya, pero subjected na siya to transverse loading between their supports. So, for members whose ends are restrained against rotation in the plane of bending, Cm is equal to 0.85. Kapag naman siya ay unrestrained against rotation, automatically, C sub m is equal to 1. So, proceed tayo dito sa example. So, steel column 3.6 long and hinged at both ends is used to carry an axial load of 1,000 kilonewton. So, meron tayong column na hinge at both ends. And then 3.6 meters long. Tapos sabi dito, meron siyang axial load na 1,000 kilonewton. And then the column is subject to end moments, a reverse curvature with M1 is equal to 0.9, di ba yung 90% daw ng M2. Therefore, kung kukunin natin yung ratio ng M1 to M2, this is 0.9 M2 over M2. So, yung ratio niya is 0.9. So, mamaya magamit natin yan. The allowable axial stress, given na rin yung F sub A is equal to 115 MPa and the allowable bending stress is equal to 149 megapascal. So, both axes na to for X and Y axis. The properties of the section are as follows. So, given na din yung area and then the section modulus, the radius of gyration, and the yield strength and modulus of elasticity. So, ang tanong, determine the following. For letter A, the computed actual axial stress of the column. So, para makuha yung actual axial stress niya, dinivide lang natin yung area, yung axial load by its area. So, we have 1,000 kilonewton divided by yung given na area na 0.013 squared meter. That is equal to 76,923 kilopascal. So, para ma-identify natin kung siya ba ay pasok dun sa small or large axial compression, kunin natin yung ratio nung actual axial stress nung column versus nung sa allowable. So, 76.92 divided by 115 is equal to 0.669. That is greater than 0.15. Therefore, we are going to use the criterion for large axial compression. So, ito yung mga formula niya, di ba? So, unahin natin yung sa stability interaction criterion. So, para magamit natin tong formula na to, una, meron na tayo nito, value nitong dalawa. So, ang wala na lang is yung sa C sub mx and then the value for F prime sub ex. So, unahin natin yung sa C sub m. So, para makuha natin yung value ng C sub m, sabi dito, 'di ba, hinge at both ends naman siya, so hindi siya pasok dito sa letter A. So, malamang sa B siya papasok kasi braced siya against joint translation pero hindi siya subjected sa transverse loading. So, ito yung formula natin. So, ito na yon. Isa-substitute na natin yung C sub M. Okay. Yung para makuha pala yung sign nung para sa M sub 1 and M sub 2. So, may nakalagay dito na reverse curvature. Indicated na dun sa problem na siya ay reverse curvature. Therefore, positive yung ratio na gagamitin natin ng M sub 1 at M sub 2. So, substituting the values, we have 0.6 minus 0.4 multiplied by 0.9. That is equal to 0.24. Since less than 0.4 siya, ang gagamitin pa rin natin ng value ng C sub M is 0.4 kasi andun sa condition na dapat C sub M is should be greater than or equal to 0.4. So, meron na tayong C sub M. Kunin naman natin yung F prime E. So, kung mapapansin nyo dito, di ba yung formula natin is for X and Y. Since mapapansin ninyo, isa lang yung binigay niyang allowable bending stress, isa lang yung ano niya, yung binigay niya ring R sub B or the radius of gyration. Therefore ito na yung ano niya, yung governing value. Ano, 'di ba? Kino-compare natin yung value ng radius of gyration ng x and y. So, kunwari, siguro ang assumption dito is along one axis lang siya ano, isang axis lang yung merong bending, ano. So, binigay naman na niya yung radius of gyration. So, substitute lang natin, ano. So, yung formula for F sub E is given na din dito sa taas. We have F sub E, F prime E is equal to 12 pi squared E all over 23 multiplied by KLB over R sub B. So, kung mapapansin nyo, ito lang din yung Euler critical stress. Ano? So, itong KL over R is the governing slenderness ratio natin dati. Ano? So, balik tayo doon. Substitute lang natin ulit yung mga given. So, we have F prime E is equal to 702.16. So, considering bending on strong axis only, F sub Y is equal to 0. Andito na pala, ano. So, for stability interaction criterion, ito na yung naging value nung bending stress along the strong axis. So, doon naman tayo sa strength interaction criterion. So, ayan, may nakuha din tayong value doon nung bending stress. Ano? So, ang gagawin natin, 'di ba dalawa yung criterion, ipagko-compare natin. Kung alin yung mas mababa, yun yung mag-govern. Ano? So, thus the actual bending stress is 71.97. Ano, yun yung hinahanap natin dito, the actual bending stress of the column. And pagdating naman dun sa moment capacity of the column, so yung na-compute nating actual bending stress niya na 71.97, i-equate lang natin dun sa bending stress formula natin. That is equal to M over the section modulus. So, the capacity nung column natin is 8.63 kilonewton meter. So, ganun lang yung sa combined stress natin, ano. So, that's all. Thank you.